this video, we want to learn about intermediate value theorem, or IVT. We sometimes say only IVT. But what is intermediate value theorem? Suppose we have a function f which is continuous on the closed interval a to b, and f of a is not equal to f of b. So, like this figure here, f of a, the value of the function f at point A, as you can see, is different than the value of f at point B. These are different values. Now, if you choose a random value between f of a and f of b, f of a is here and f of b is here. If you choose a random value between f of a and f of b, of course in the y-axis, for example, let's say randomly we choose here, and we say this point k. So if we choose a random value like k between f of a and f of b, then definitely there is at least a number. Then there is at least a number like c between a and b that the function is equal to k. In this figure, where is k? Simply, if you draw this horizontal line, you can see that in this particular case, c is here. When x is equal to c, f of c, as you can see, is equal to k. The value of the function, this is our function, graph of our function. When x is c, the y value of the function is k. Attention! One of the most important things in the intermediate value theorem is that f should be continuous. Then we can have this result for function f. And attention, it doesn't matter where you put this k. Maybe it's here, then c would be here. Maybe you choose k here, then c is here. And always c is between a and b. So for any value k between f of a and f of b, somewhere between a and b, the function is equal to value k. Now let's see how we can use this theorem to answer the questions. The first question is this. Show that there is a solution for this equation. The equation is this: x to the 3 plus 4x minus 10 equals 0 between 1 and 2. Attention, here we don't want to find x, only we want to show that this equation has a solution, and that solution, that answer, is between 1 and 2. So we claim that somewhere between 1 and 2, maybe something like 1.6, 1.7, somewhere between 1 and 2, this equals to 0. We want to prove that this happens. Now let's see how we can use the IVT, intermediate value theorem, to prove this. The first thing to answer these type of questions is to name the equation something like f of x. We need to have a function. So we suppose f of x to be x to the 3 plus 4x minus 10. And attention, if here we had an expression, always move all the expression to the one side of the equation and then name it f of x. Here in this case we have nothing here, it's 0, so we just name this expression f of x. And attention that here f of x is a polynomial, and we know that every polynomial function is continuous. So immediately we mention f of x is continuous. Why it is important to mention this and attention to this? Because you can use IVT or intermediate value theorem if f is continuous. So you have to consider this. Now that f is continuous, we want to prove that somewhere between 1 and 2, this equals to 0. Let's see what is f of 1 and f of 2. Actually, this 1 is like a in the theorem, and this 2 is like b in the theorem. So we are going to find f of a and f of b. This is what we have to do to answer this question. If you simply calculate f of 1 and f of 2, f of 1 is 1 to the 3 plus 4 times 1 minus 10, and it equals negative 5. f of 2 is 2 to the 3 plus 4 times 2 minus 10, and it equals 4. 8 plus 8, no, 6. It equals 6. Now attention, f of 1 is negative, f of 2 is positive. We want to prove what? We want to prove that the function somewhere is equal to 0. When f of 1 is negative, f of 2 is positive, 0, we want to prove that the function is equal to 0 somewhere between 1 and 2. At 1, the function is negative. At 2, the function is positive. So somewhere between 1 and 2, the function should be equal to 0. This completely makes sense. Look at this graph, for example. Let's say 1 is here, 2 is here. Our function at 1 has a negative value, at 2 has a positive value. So if you draw a continuous function here, somewhere between 1 and 2, the function crosses x-axis, which means that the function is equal to 0, or it has a root, a solution. So now we say, from IVT, we can conclude that there is a number C between 1 and 2 such that f of c is equal to 0. Why we can have this conclusion? Attention, this 0 plays the role of number k in the IVT. If k is a number between these two numbers, then definitely there is a number c that f of c is equal to k. Because we wanted to prove that the function has a solution, so we choose k as 0. So this completes the solution of this equation. Let me show you another example of using IVT to answer questions. The question is this: if f of x equals to x plus cube root of x, show that there is a number c, show that there is a number c such that f of c equals 20. Here, the difference between this question and the previous question is that f of x is directly given to you, but you have to mention and attention that the function is continuous. The function is x plus cube root of x, and this function is always continuous for every value of x. But it is good to mention it. F of x is continuous. But attention, here for number c, we don't know in what region or what interval number c is. Just we want to prove that there is a number c in all the real numbers. So now here we have to find the numbers a and b in the intermediate value theorem. Let me remind you the intermediate value theorem. The number c is always a number between a and b. In this question which we had here, the c was between 1 and 2. But in this new question, we have no idea where is c. How we can answer this question? For finding a region for c, that f of c is equal to 20, you have to choose two numbers as a and b. Attention, you have to choose two numbers that the value of the given function at one of those numbers is less than 20, at the other one the value of the function is greater than 20, then based on the intermediate value theorem you can claim that somewhere between those two numbers the function is equal to 20. So this is the idea. Maybe you think how you can find or guess those numbers. It's very simple. Randomly choose a value for x and plug in your function. But attention, you want the first value that you choose to be less than 20. For example, you can choose 0, 1, even negative numbers you can choose to plug in for x. For example, if you choose number 1 for x, what would be the value of this function at 1? 1 plus cube root of 1. 1 plus 1 is 2. And it's obvious that this number is less than 20. Now we have to choose second value for x, that the value of the function at that point is greater than 20. So obviously you have to choose a larger number, that when you substitute that value in the function, the value of the function is greater than 20. And attention, because you want to find the value of the function at that point, it's good to choose a number that you can find the cube root of that number. For example, you can choose numbers like 1000 or 125, because cube root of 125 is simply 5. But not necessarily you have to choose numbers like this. You can choose any number that the value of the function is greater than 20. But the better numbers that you can choose are something like 1000, 125, and so on. But let's say you choose randomly 100. If you plug in 100 for x, it would be 100 plus cube root of 100. We cannot find the cube root of 100 without a calculator, so we leave it like this. But it's obvious that this value is greater than 20, and this is enough for us. We don't need the exact value of the function at point 100. So we leave it like that. Now, based on the intermediate value theorem, now we say from IVT we can conclude that there is a number c between 1 and 100. Maybe you choose other numbers, not necessarily these numbers. It's up to you. But one of the numbers should make the function less than 20, the other one greater than 20. This is the important thing you have to consider. Otherwise, you are free to choose number A and B. I choose 1 and 100. Okay, so then let's review this. From IVT, we can conclude that there is a number C between 1 and 100 such that f of c is 20. Why we can have this conclusion? Because 20 is between 2, is a number between 2 and 100 plus cube root of 100. This is obvious that 20 is between these two numbers. So this completes the solution of this question. I hope you like this video and see you in the next videos.